All right, geometry. We are talking about trapezoids and kites today, and then next week we're going to be testing over chapter 6. So to start off with here, two properties of trapezoids that we have are, first of all, there's only one pair of opposite parallel sides. So in our picture here, that's the top and the bottom. Those two sides are parallel. And then the other thing is that consecutive angles between parallel lines are supplementary. So in that case, it would be like this angle and this angle. Those are supplementary. Or in the other side, we have this angle and this angle. So the top and the bottom, or the bottom and the one right above it, are parallel or are supplementary, add up to 180. And then when you talk about isosceles trapezoids, you've got a few more properties that we can kind of point out. So one is the non-parallel sides are congruent, which is why they're called isosceles. And then diagonals are congruent. So that means here to here, here to here, those are congruent. Base angles are congruent as well, so that'd be like this angle here and this angle here are congruent, or in the other case, this angle and this angle are also congruent. Those are base angles. And then finally, opposite angles are supplementary, so that's just because these two angles are supplementary, so are those. Okay, so let's look at a few examples here. Looking at number 1, 87 degrees and 51 degrees. Well, if I know 51 and 87, that doesn't really have anything to do with each other. But what it does tell me is that this angle and this angle add up to 190. So I can use 51 to say, okay, well, 180 minus 51 is going to give me this angle, which is 129. Okay. And same thing over here. I've got, okay, well, this is 87, so this one is 180 minus 87, which is going to be 93. Okay, so angle M is 93, angle K is 129, and we're done. Okay, so that'd be basically the same scenario for number 2. Okay, so if you really wanted to find those, again, 60, that's 180 minus 62. Okay, so that would be 118. And this was the same deal, 180 minus 31, which is going to be 149. And again, use your calculator if you're not sure off the top of your head. Okay, so angle D, 118, angle C, 149. All right, so looking at these next two, looking at 4, for instance. Number 4, a lot of the time we're setting things equal. In this case, these are not equal. These are supplementary. So I would actually add these together to equal 180 since they are supplementary. Okay, so that gives me 19x, that gives me negative 10 equals 180. So I add 10 to both sides, 19x equals 190. So when I divide by 19, I get x equals 10. Well, x equals 10 wasn't what we were looking for. It said find the measure of angle R. So in that case, I would just take that 10, plug it into angle R, and when I do so, I get 70 minus 13, which gives me 57. So angle R equals 57. Okay? So when we start talking about isosceles triangles, that's where some of those other properties come into play. So like here, it says DG is congruent to what? And that's EF, because it's isosceles. And in an isosceles triangle, the diagonals are also congruent. So DF is congruent to EG, or GE, either way. Okay? And with that being said, we can also find some other things about it based on what we're given. So, again, this is isosceles, and if this is 112, the base angles are congruent. So this is also 112 degrees. And if that's 112, well, these two are supplementary to 112, right? So 180 minus 112 is going to give me 68. 68. So I just subtract from 180 and get the other two measures. All right. So let's go to the back side here, talking about a couple other things with isosceles triangles. So like for instance number 10, it's telling me MP is 16x minus 13. It's telling me NO is 9x plus 8. And it's also telling me PN, so that's one of the diagonals, is 5y plus 19. And MO, the other diagonal, is 12y minus 37. So how am I going to find these two x and y values? Well, if it's isosceles, obviously these are equal. So 16x minus 13 equals 9x plus 8. And then I would solve by getting x by itself or to one side and get the constant to the other side. So I'm kind of skipping some steps here, but 7x equals 21 and x equals 3. And then the same deal for the y value. Diagonals are congruent, so 5y plus 19 equals 12y minus 37. So again, I'm going to get y on the same side, which gives me 7y. I'm going to add 37 to the other side, which gives me 56. Divide by 7, get y equals 8. And there we are. Okay, so kind of the same deal here. With 10 and 11, we're just going to kind of set these up. We'll do them. So number 10, these are base angles of an isosceles, which means those are congruent. So 2x plus 27 equals 5x minus 12. Okay, so I'm going to subtract 2x to get it on the same side. That gives me 3x. I'm going to go ahead and add 12 to the other side, which gives me 39. Well, divide by 33 to both sides, I get 13. Okay, and if that's 13, I need to find the missing angles. Well, let's just kind of find one of these. If I plug it into angle C, for instance, I get 5 times 13, which is 65, minus 12. 65 minus 12 is 53. So, if this is 53, this is also 53. So C and D are 53. And then A and C, or A and B, are supplementary to that. So I'm just going 180 minus 53, which is 127. And there we go. So very similar to that, I'm using this time the fact that these are not congruent, but supplementary. So I'm adding these two together to get 180. So that'd be 14x, negative 33 plus 17 is negative 16, equals 180. And then I'm doing the same thing. So add 16 to both sides. I get 14x equals 196. Divide by 14, I get x equals 14. So plug 14 right back in, and we're going to end up with, what are we going to end up with? 14 times 4 would be 56. So this is 56 here, which means this is 56. Okay, so M and L are 56. And if that's 56, 180 minus 56 would be 124. Okay, and that's that. Those are isosceles trapezoids. Okay, so on to the next one. We're talking about mid-segment of a trapezoid. So a mid-segment of a trapezoid is something that connects, it's a line that connects the midpoint of each of the sides together of a trapezoid. So EF is the mid-segment of this trapezoid. Okay, so in this case, I've got one property of a mid-segment. Well, first of all, let's just say, okay, these two segments are equal because that's a midpoint. But second of all, if you have a mid-segment, it is parallel to both of the two that are already parallel. So in this case, AB and EF and DC are all parallel to each other. And then the other thing is that EF, the mid-segment, is going to be the two bases added together and divided by 2. Okay, so the sum of the bases divided by 2. Okay, so with that being said, take a look at numbers 1 and 3. So if AB is the top and DC is the bottom, find EF. Well, EF is going to equal those two added together divided by 2. So 14 plus 26 is going to be 40 divided by 2, and so EF equals 20. Well, kind of the same thing down here, except EF is given to us. So 22 equals AB is the one that's missing plus 38 divided by 2. Well, to solve for AB, I got to get rid of that 2 on the bottom. So I'm going to multiply both sides by 2 and get 44 equals AB plus 38. And then I subtract 38 to both sides. So I get 6 for AB. And there's that. Okay. So using that mid-segment, we can also find missing parts like these. Okay, so let's go ahead and just look at the toughest one here. Here our UV is the mid-segment. So 8x minus 3 equals the other two added together. So x plus 7 plus 6x plus 5. All that divided by 2. Well, just like last time, I got to get rid of that 2 on the bottom by multiplying. But when you multiply, I got to multiply the whole side. So make sure you're distributing. That's 16x minus 6 equals. And then let's go ahead and combine like terms. X plus 6x is 7x. 7 plus 5 is 12. And now we can go ahead and solve. So subtract x to the other side. I get 9x. And let's go ahead and add 6 to both sides. That's going to be 18. And then we divide by 9. Get x equals 2. Well, didn't say find x, it said find UV. So I just got to plug it back in. 2 times 8 is 16 minus 3, so UV equals 13. There we are. So that's mid-segment. And then finally, the last thing we need to talk about is kites. A kite. So a kite has, first of all, 2 pairs of consecutive congruent sides. So like these two sides are right next to each other, and they're equal, as are these 2 sides, which that makes a kite. Okay, so another thing is there's 1 pair of opposite sides that are congruent. So look between the 2 consecutive congruent parts. So the one that splits up the 2 congruent parts, those 2 are going to be the equal ones. Okay, so B and D. And then finally, diagonals are indeed perpendicular. So AC and BD are perpendicular, making any center angle a right angle. Okay? So using that information, we can find a lot of stuff. Okay? So like, for instance, number 1, I have 83 and 43. I want to find B and D. Well, I already know they're equal, but the problem is I don't know what they are. But since we know these two, I can go ahead and use that to get our sum. So remember, a triangle adds up to 180, but then again, a four-sided figure, a quadrilateral, adds up to 360. So I've got these two added up to 360. So 85 plus 43 is going to be 128. Okay, and that means out of 360, I got to subtract 128, and I'm going to get 232. So that's what's left. So that means these two angles are half and half. So 232 divided by 2 is going to be 116 each. So those are 116, 116. Okay. So another way you could do that is just setting these equal to x, and I could have added those up equal to 360 and solved it that way. Okay. So looking at number 3, kind of the same situation, except we've got diagonals that are splitting up those angles. So if this is 37, this is also 37. Okay, and if that's 37 and 37, don't forget we have a triangle here. Okay, so if that's 37 and 37, I can find this whole angle. So 37 plus 37 is 74. So subtract 180 minus 74, and I get 106. So if that's 106, that means these two parts are 53 and 53. Okay. And so, as I'm going through what I need to find, PTQ is right in the middle, which is 90, because the diagonals are perpendicular. PQT is 53, which we both found. And QRT is the 37 that we already found as well. Okay. And so, knowing all that information, let's look at number 6. A lot of angles to find here. Well, let's get the easy ones. This is 73, which means 5 is 73. This is 46, which means 1 is 46. Okay? And if that's 46 and 46, then 46 plus 46 gives us 92, and 180 minus 92, since again, look at the triangle that's created here. So I can get that whole angle there, 92. It's going to be 78. Yeah. No, that's wrong. 88. Okay. So that means this whole thing is 88. Split it in half, I've got 44 and 44. So 2 and 3 are 44 and 44. Okay. So angle 4 is 90. We already know that because that's the middle angle. And if 5 is 73, we can go ahead and use all that information. So look at the triangle again that's made. 90 plus 73 is 163. So 180 minus 163 gives us 17. Yeah. 17 degrees. So that's here, 7 is 17 degrees. And here, also 17 degrees. Okay. And there's that. So, again, use the triangles in the problem. Okay. Last one. I've got 14 is here. WR is 8. So, that information given, I got to find RZ. Well, I know this is 14 as well. Once again, look at the triangle that's made. something we did a lot with the right triangles and a rectangle and a rhombus. We can use the Pythagorean theorem to find x. So x squared plus 8 squared equals 14 squared. And so that's 64, 196. Subtract 64 to both sides. I get x squared equals 132. Square root of that. X equals 11 point something, but let's use the calculator just to make sure. Square root of 132 equals 11.5. And there we are. Okay, so there will be a short assignment given to you. If you don't have the paper or can't print it out, you can just use your own paper. I will tell you which numbers to do along with the assignment. Okay? Peace.